All right, so let's just quickly go ahead and jump into your favorite IDE. So like what I've mentioned before, in this case, I'm using VS Code. So inside my IDE, this is the problem that we are trying to solve, which can be found on this cargo link that I showed you earlier on. So in this case, we are simply going to do some binary classification. So what I've done here is I've downloaded the data from the cargo website, and I've put them in a folder called bank term deposit, right? And I have my test data and my training data, right? So these are just two CSV files that I've downloaded, right? So we're going to be using these two CSV files to train our model and then to test it as well, right? So first thing that we need to do here is we need to probably load our dataset, right? So before we load our dataset, we need to import a couple of libraries, right? So in this case, I'm simply going to import these. So we need NumPy, we need pandas, right? We need this clear output to clear some things that we don't necessarily need to display. And then we need TensorFlow, right? So I'm simply going to import these, right? So it has run successfully, right? Then the next thing that I need to do here is I need now to load the dataset, right? So I can simply say loading the dataset, right? So this is the dataset that I've downloaded that is in that folder, right? So let me simply go ahead. I'm going to be using pandas to load this data. So to load the data, I'm simply going to separate the data and say I've got DS trained data, which I'm going to use the pandas. We have read CSV, right? And then we need to pass the file path. So in this case, my file path is data, then / in this case, I think it's bank term deposits. I don't think there's predictions. And then I have train.csv, right? So this is my data frame for my training data. So I'm simply going to do the same for my testing data, right? So for my testing data, I'll simply say testing, right? And then here I'll reference test.csv, right? So here we're using the pandas to be able to create, to load these data set as data frames, right? So let's simply go ahead and run, right? So as you can see, it has run. So to inspect the data, I'm simply going to inspect the training data for now. So I'm simply going to use the head function, which will sort of like outline the data that we have. So this is the kind of data that we have. So as you've seen from the website, we had the age, the job, marital, education, default, balance, housing, loans, contract, month, etc, and previous, and outcome, right? So this is the data set that we have, right? And then the outcome that we are trying to predict, in this case, that will be our label, is this Y outcome, right? So here we can actually see that from these first 5 clients that we have print from our data frame, we can actually see that all these 5 clients that were contacted, none of them has taken this campaign, right? This is what we can just quickly look, right? So what we can actually do here is we can actually go ahead and just print some information so that we can actually go ahead and get a better understanding of the kind of data set that we're dealing with. So here I'm simply going to say .info, right? So it's not here, it's dftrain.info. Okay, right? So these are the data types, right, that we're dealing with, right? So we can actually see that we have around 45,000 entries, right, of data, right, in our training data set, right? And we have numerical and categorical data, right? So we have numerical data, which is being represented by the int64, and then we also have these objects that I'm assuming they represent the categorical data. So in order for us to train our machine learning, we need to take note of this, right? Because for our features, it's combining both numerical and categorical data. So for now, it's okay. Let's just keep it that way. I'll come back to this point, right? So the next thing that we just want to quickly look at is, let's look at our label, right? So let's just look at our label, and then I just need to do value counts, right? So if I look at this, right, what do we have, right? So we can actually see that for our output label, which is y, output label is the one that we're trying to predict, right? So remember, like what I've said is, in order to build a deep learning model, you have some sort of like features or data set, right? So all these are the features that we have. So we want to build a model that will somehow be able to create rules to which why we had this sort of like behavior. Why are these clients saying no? For example, these first clients, why did they not opt in for this campaign, right? So that's what we're trying to do, right? But we'll do it using all these feature datas, and then what we're trying to predict is the label, right? So let's just take a look at the label. So from the label, we can actually see that we have over 39,000 records that have clients that have said no, and then the clients that have accepted the campaign, they are just 5,000, right? So clearly we can see that most of the clients, they said no, and then the list of the clients, they said yes, right? So in this case, nevertheless, in as much here, you can actually see that our data is not properly balanced, right? But for data balancing, there are ways where you can actually go ahead and solve this using undersampling, oversampling, or the smart approach, right? So that's beyond the scope of this tutorial. I'll do that in the next video that I'll release after this one, in terms of handling overfitting issues, right? So we explain what those are in a bit, but just know that for now we have 39,000 records for clients who have said no, and 5,000 records for the clients who have said yes. So let's just simply now go ahead and try to visualize this data, right? So now that we have loaded the data set, I'm simply going to create another markdown, and let's say visualizing the data, right? So for visualizing the data, remember we installed MATLAB plot for plotting the data. So in this case, I'm simply going to start by visualizing the training data for the job, for the age, for example. Let's start with the age, and then I'm simply going to say value counts, and then I'm going to plot a bar graph. Or maybe without plotting. So for the age, let me just quickly go ahead and plot a histogram instead. With beans, I can set beans to 20, right? So let's just quickly go ahead and plot a histogram for now. All right. So this is the data that we can actually pull in terms of the age, right? So we can actually see that most of the clients that participated in this campaign, they're in the range of age 30 to 60, with the most ones being around 30 to 40. There were so many clients in that range, right? This is what you can quickly see by just looking at this data. And also we can also tell that our data is sort of like normally distributed, and it actually makes sense, right? Because probably the bank was not pushing so many campaigns to the elderly, right? Because you can see from 60 years going to 90, there were less and less clients that were contacted probably by this bank, right? So mainly they're targeting these clients from in the range of 30 to 50, right? Roughly, right? So this is the data set for the age, right? This is what you can see. Then let's quickly go ahead and look at the job, right? So we also had the job, which was sort of like a categorical data set, right? So let's simply go ahead and plot that. So for the job, I'm simply going to plot a bar graph. So in this case, I'm going to say dot job, and then in this case we now need to use value counts, and then plot, and then the kind is going to be a bar graph, but it's going to be a horizontal bar graph, right? So let's just plot this one. Okay, right? So the reason why I've said this is categorical data is because of this, right? So can you actually see? You can actually see that most of the clients that participated in this campaign, most of them were blue collar clients, followed by the management clients that were called by the bank, technicians, admins, and the list being the unknown status and the students, right? So it makes sense again. Probably these other people are the ones that have responsibilities as compared to maybe the student or these unknown people, right? Or the retired people, right? So the bank is targeting the people who work, right? who commit day to day, the white collar jobs, and these other kind of people, right? So that's what you can pick from the data set, right? So it's very important, right, to analyze this data before building the model, because sometimes you might be surprised by seeing some other data sets that might affect your model. So you need to be in a position to catch it before you start building a model. So it's very important that we analyze this data. So let's just take a look at the marital status. So in this case, we have over 25,000 people who are married, around 1,200 people, 12,000 people who are not married, who are single. Then the divorced people, I think they're around 5,000, right? So this is the data that we have, and it's not evenly distributed, but we can work with this. Probably the married people, I don't know, maybe they're being targeted much by the bank, but most of these clients for these banks, most of them, they're married, followed by the single, and then the divorced being the list of the clients, right? So one other thing that we can also look at, we have something called default, right? So default, I'm simply going to paste it. This is the same code that we've been writing, so I'm simply going to paste it and plot it as a bar graph. So for this default, right, so this one, you can actually see that the client's default, what was the explanation for default, right? So let's just simply go ahead and switch to the Chrome, right? So they said default, what was default? So whether the customer has credit in default or not, right? This is also categorical data. So default tells us whether a client has a default or not. You can actually see that for this default, a lot of the clients, they are not default, right? And then only a few hundreds of these clients are in default, right? So this data set might not help us, right? This might cause problems for us, right? So and also it's very imbalanced, right, as you can see. So we don't want our model to be sort of like directed to a specific goal. We need it to be able to learn on its own, right? So to us, this data, it doesn't mean anything. So this is useless data. So I will drop this data set in future, right? So but just take note of it. So maybe I can just put some notes here. I can say default is imbalance to drop the column. Maybe when you are doing what we call feature engineering, right? So we'll drop this column later on, right? So I'm just going to put some notes so that we'll remember this, right? Maybe one thing that let's just try to look at some more numerical data set, right? So some more numerical data set, we have the day, right? So this is the day. It's almost evenly distributed, so this data set is important. We'll consider it, right? So for the most part, I think you get the gist. So the idea here is you need to explore all these columns, right? All this data set that we have, right? So that you get sort of like an overall picture of what the data you're dealing with looks like, right? So in this case we've already seen that this default data set is not good data, because it's like we almost have no one that is not in that is defaulted, because this ratio it's just ridiculous. So we'll drop this, right? So from this point you can actually go ahead and continue exploring this. right? So in the next section of this video, we are now going to look at how we can actually go ahead and clean this data set. So see you in the next one.